everybody, welcome to our Tech Talk. Today we have Kat Lefevre, who works over at the Martin Regional Library, presenting on 3D modeling and 3D printers here at Tulsa City-County Library. So Kat, I will let you take it away.
All right, thank you, Caitlin. So I am not an expert in this. I think people can be in 3D printing for a decade and still not be an expert. So what I'm going to share are things that I have found work. There are other people who do things differently, but this is what works for me and has worked for us at Martin. So I'm going to hit a whole bunch of stuff. We're going to just fly through things. I do have some links in the slides, and I'll share the slide deck. Caitlin, sorry, I forgot to check with you about that. So I'll share the slide deck afterwards. So let's get started. Let's see, get the right thing clicking here. There we go. So we're going to cover 6 sections. As I said, we're going to fly through them. I think, Caitlin, you said we can have questions as we go, and then we'll also have a question and answer section at the end. So let's start real quick with the basics. What is 3D printing? So it started out as a way to make models of things, to proof concepts, all that kind of a thing. And it is what is known as additive manufacturing. So like a CNC carver, it takes material away. What we're doing is building it up. So that's why it's known as additive manufacturing. So you can't start with a 2-dimensional object. You do need to start with a 3-dimensional object. If you have something 2-dimensional, you can do it kind of like a flat, thick piece, but it won't have that 3-dimensionality. So you need to use some kind of computer-aided design program. And that sounds way scary. It's not bad at all, really, I promise. And so once you've done that and created a 3D object, you'll put it through some other software and then send it to the printer to be made. So there are lots and lots and lots of options for materials, colors. You can glue things together and sand them and paint them. One of the popular things to do right now is the Mandalorian helmet. And so most people don't have printers that will do the whole helmet because, it's like a head-sized thing. So they'll cut it apart and then print the pieces and glue them together. So there's a lot of finishing that you can do at the end. So that's a real quick overview of 3D printing. And we're going to get into a little bit more with the 3D printer parts. So the next couple things I'm going to show you apply in a very general way to all printers. They're all this kind of printer is going to use a filament. And so I have a little line coming up off the screen. It comes around down into the extruder. So the extruder has those little wheel type things there. And depending on the different printer, those motors might be in a different spot. But so it heats the filament, it forces it kind of down through and heats it in this area, and then that filament comes out onto the print bed. So this particular little model here, it's kind of far into the process, but it starts down at the very bed. So it builds on that first layer and moves up. The material moves up. So the printers that we have at the regionals are the Ultimaker 3. And I said specifically the regional libraries because at Central, they have a little bit different ones. They have newer ones that are bigger. So they have a much bigger build volume. So build volume is always measured in millimeters. We use metric in 3D printing. So if you use inches, you're going to have to convert and then convert back. So just start in millimeters. I have one here at my house. I have the Kitty Tech, and that is the one, actually this machine right here, back behind me. I don't have it going because it's super loud. I mean, they're all kind of loud, but that one, it would be distracting. So there are lots of other ones. One of the other really popular ones is the Creality CR10. There are other ones as well, but you can see compared to the other two that we saw, this one is quite a bit different. So this version, they'll run anywhere from $150 to $500, depending on what you've got there. But it comes as a kit. So this is not typically a beginner one. So some of the other ones are going to be, anywhere $600, $700 to $3,000, depending on features and all that. But while the Creality is a great system, it's not fantastic for beginners. So if you can come and kind of learn on one of the ones that we have at the library, and then decide to build one, you'll kind of have a little bit better starting point. So tons and tons of different styles, brands, experience levels. Like I said, you can do a kit, you can do the other kind. So we encourage you to come talk to us. We're happy to answer questions and help kind of with that process. So one of the heart basically can't do anything 3D printing if you don't have filament. So the filament that we use, it is a thermoplastic. It melts with heat and it squeezes it out and extrudes it onto that build plate. So you can use tons and tons of different types. We use PLA primarily, and I'll talk a little bit more about that in a second. There are lots of other ones. We also have nylon, which is a little bit challenging. Well, it's really challenging to use, honestly. There's flexible filament, there is clear filament, there's all kinds of different stuff. So lots of colors, lots of materials. We use 2.85 millimeter PLA, polylactic acid filament. So my printer that I have uses 1.75 millimeter. So those two are not, you can't use them on each one. So I've got to have, I have my filament here at home, and then I have some filament that I bought to use on the printer at work. So they'll call it a 2.85 millimeter or sometimes a 3 millimeter. It's pretty much the same thing. So the PLA is biodegradable, and when you heat it up, it kind of smells like waffles. It's pretty fun. So you can, here's the caveat. For example, I have, let's see if I can show you this. This is a cookie cutter. So what happens when you use any 3D printed thing pretty much with food is that it has the layers, and you can kind of hear the layers as I scratch it. Food particles will get caught in those layers, and bacteria will get caught. So you don't want to use it for holding food. Like, you don't want a cup that you'll drink out of, because unless you're going to put it in the dishwasher, which will distort it, then it's not going to be safe to use. So that's my little caveat there. You can do things like coat it with resin. There's lots of stuff on the internet about that, so I'm not going to talk much about that. So one of the advantages of PLA is that it is the easiest to print with. It's very forgiving. You can do a lot with it. It does have a ton of colors and materials that it comes in, like you get a stone look, you can get all kinds of different ones. It does have the lowest temperature tolerance, and what that means is that if it's a hot day, not like today, obviously, but if it's a hot day and you leave it in your car, it's going to melt. It's going to just kind of deform and distort a bit. So same thing if you can't really put it into the dishwasher to clean it. So that's going to be way too hot. It'll get all weird. So that is a real quick talk about the 3D printer parts. So that's the physical portion of it. Now we're going to get into the digital portion. So files, where do you get them? The answer is the internet, honestly, but there are lots of different places you can get it. So we're just going to touch on this really, really briefly. The idea here is that a 3D printer cannot recognize every type of 3D model out there. So it's got, what the process is, you get the file type and you have to put it through a converter before it can go to the printer. So that leads us to importing a file. So you'll go out and you'll find your file, you import it into a slicer, and that slicer takes that object and puts it into layers so that it can then extrude that and build it up. So you've imported the file into the slicer, you slice it, and then you can export it, and that exported file goes to the printer. So it's this kind of, we've got to translate it. So where do you get the file? There are lots and lots and lots of places. The thing that you want to look for is an STL file. So STL stands for stereolithography. That means it is a 3D object. It's not a flat object. You can also use an OBJ file. So the difference with that is that it retains a lot of the details that make it look good to our eyes. The conversion software, the slicer, does not care about any of that. So that's why you can get away with an STL file. So the STL files tend to be a little bit smaller because they don't have all that other information. So my favorite place to get files is Thingiverse. If you go on Thingiverse, be prepared to lose a couple hours. And it's overwhelming with the number of things on there. But I love it. And also be prepared that their search algorithm is not the best. It's not terrible, but it's not the best. So you might have to try a bunch of different keywords. Look at, if you find something that's kind of close, you might look, sometimes they'll be tagged, sometimes they won't be, but you can kind of poke around and get there. And that's part of why you can lose hours doing that. So Thingiverse, most of these things that I'm going to talk about are, they're crowdsourced. So people just put files up there. So the quality may vary greatly. So as long as you go into it with your eyes open, that's good. I was really bad-mouthing Thingiverse, I don't know, 6 months ago or so, they kind of changed the whole website, and you couldn't find anything, and it was only displaying like 3 things. It's terrible. Anyway, it's much better now. So sometimes they break the site, but it usually comes back. If you are feeling brave, you can create your own file, and you can use Tinkercad. That is an Autodesk. It's an Autodesk family. So if you have an Autodesk account, you can log into Tinkercad with that. Both of these things are free. You just have to have an account to use them. So other kind of higher level things are Vectory, Mesh Mixer, Sculptress, and Blender. I honestly have not used any of those. My daughter uses Blender and Sculptress all the time. But what you're basically looking for on all of those is the mesh of the object. That's what the slicer is going to look at, is that mesh. So I have a screen cap here of one of my collections pages on Thingiverse. So, I've got my thing here. I call myself a novice because honestly, I'll probably be a novice for the next decade. There's so much out there to know. So I have a couple of collections, and you can organize things a little bit. It's not fantastic again, but it holds them. I have technically made 15 things. Every time you go in and customize something, it'll add it to your makes. And I have a whole lot of likes because I'll go through and I'll just hit the like button, and then I'll go through and sort those things into my collections many times. But 543 is really kind of overwhelming when I start looking for something. So it's not usually a quick process just because I get distracted. So if you want to build your own things in Tinkercad, you can absolutely do that. This is a screen cap, and it gives them all funny names. This is actually one that's my filament holder spacer. So on my printer, I have changed it a bit, and I've mounted this full holder up there. But I needed to have like 2 grommets to hold it in place, and so that's what I was creating here. So the idea is that you have a shape and you have holes, and that's pretty much it. So there's a lot you can do though. This is like 5 or 6 shapes combined over here, with a hole and things, above. Anyway, there's a lot that can go on there. And then this is the other part of that. So they kind of fit together with another thing in the middle. Anyway, it's a long, involved process for me to get all that right. But it's pretty easy to use once you get it. So let's move on to Cura and slicing. So this is where we're going to kind of get into a little bit more detail. So the Cura software is a free download. You do have to download it. It is not a web-based app, unlike Thingiverse and Tinkercad. So it is a free download. You'll go to ultimaker.com, or you can, of course, just Google Cura download. That works too. I like it to do the same place. They will ask you some questions, but you just answer those questions and download it, and you'll be good to go. So one of the things to be aware of is there are frequent updates. And by frequent, I mean sometimes 2 in a week, sometimes it's a month, sometimes it's 2 months, but there are a lot of updates. So at the library at Martin, at least, we're using 4.4.0, and I think they're at 4.9. I can't remember exactly what it is, but there are frequent updates, but it's just not, honestly, it's not worth it to update every single time unless they're fixing some kind of significant thing. So one of the things that I love about Cura and Ultimaker is the amount of information that they share. So a lot of the screen caps that I have about various software things that you'll see here in a minute are from Ultimaker. I think they're all from Ultimaker. And I do have links underneath each slide for where I got the stuff. So as you're working with the software, there are 2 ways to open a new project. And the reason I put this here is that it took me an embarrassingly long amount of time to figure this out. So you can either open a whole new Cura instance, and what that is if you go in, let's say you've downloaded a whole bunch of stuff, and you double click on the file, it's going to open Cura, and then you say, oh wait, I wanted this one too, and you double click on that file, it's going to open a whole new thing. So you're going to have sometimes a lot of different Cura windows open, and they're all going to have their own build space and be unique things. If you want to put 2 things on the same build plate, you will need to have an open thing with that, whatever that model is, and then you'll go up into the file and go file open, and that'll open it onto that same build plate. Or you can also copy and paste from one instance to the other. So there are a couple ways to do that, but just one of those, that's kind of one of those little weird things that really tripped me up for a little while. So when you first open the software, you're going to see kind of the standard file settings up at the top here. And you'll of course have this little open window here. So in this case, I would use the open or the file open either way to get an object there. So this one, I just opened Cura and then opened the thing. I didn't double click on a file that I had downloaded and then opened it. So anyway, that's just like a side note. So looking a little bit closer at the software, you have there on the left, you've got kind of this mock-up of the printer itself, and here's your build plate. So one of the things I want to point out are these little grayed out areas. These are your margins. It will not let you place an object right there. So while it looks like you've got an 8x8 space, 8 inches, sorry, you don't actually have that much. It's just a little bit narrower. So you can push that a little bit. What I found is that as you get really close to these edges, sometimes it'll lift a little bit, like it's not totally uniform on the build plate, so the edges will lift just a little bit. So I like, if I'm printing the same thing a whole bunch of times, I will typically try to not have things in that around the edges too much. So, and if you're wondering what you would want to print 40 bajillion times, we were doing when the pandemic first hit, we had the ear savers that went across, hold the masks, kind of hold it back from your ears. And so I think I put 12 on one plate, and it was a complete disaster. I got like 7 good ones out of that. So then I scaled it back down. But we're really trying to ramp up production. I have my tower back here of items, and this is what I'm going to use in the thing. So I do quilting as well, as does my mom and a couple other people, and so this is for holding the binding, the outside edge of the quilt, basically. So this is something I got very excited about. So my mom doesn't know it yet, but she's getting some of these for her birthday, which is next week. So I've been printing a whole bunch of them. So onward. So one of the things I'll point out, and we're going to get into this, is you've got your open here. You've got your 2 nozzles here that show what you currently have loaded. You can change that later. It's also right here, these settings right here. So we'll go over all this here in just a second, but this doesn't always pop up. And so if you click up in this section here, it'll pop that down, and then you can use this little 3-dot thing. It's not quite a hamburger, but anyway, you can pull that down to see the rest of those more advanced settings. So one of the things we always start with here is the profile. So in this case, it's normal. It's 0.15 millimeter is our layer height. And we'll talk more about resolution layer height here in just a second. But your profile here, you can build a profile and change a whole bunch of settings and then save those settings as that profile. So while it looks like this is where you would change your layer height, you're changing everything about it. And so first time you change that, it'll say, do you want to keep this profile? And you can decide if you want to or not, and then you can come back to that same profile later. So like with this, if I wanted to change a couple different things about how it was printing and apply that to another object later, I would want to save that profile. Moving on. That was a lot, sorry. So we talked about profile. So the default here is you have these different layer heights. So you've got extra fine, which is 0.06 millimeters. That's very small. So you can either have really small and very fine layer heights with a lot of really high resolution, so you're really going to see all those little details, or you can have speed. You cannot have both. It's one of those inverse relationships. So that's why it's extra fine, normal, and then fast. That's why that fast setting says fast. It's because that speed is going to, the faster you go, the less detail you're going to have. So that's just kind of one of those little trade-offs. And I have a slide that really demonstrates that here coming up. So this picture, this comes from all3dp.com, which is a fantastic resource. It's a really, really good resource. But this shows the different layer heights. So this is not the same picture zoomed in. This is 3 different pieces of print, 3 different prints. And they're the same height. So you can see that the one on the left is a very small layer height, and then it gets bigger as you go across. So this next picture is one of my all-time favorites for illustrating the differences. So I hate that it's in red because red is kind of weird, but the one on the left is it's like, I'm not going to say it was like a glue gun, but it was a huge nozzle. A 2mm extrusion width is huge. The standard size of the extruder, the hole that it's coming out of, is the 0.4mm. So to have a 2mm, that's just humongous. And so as you can see, it's also really fast. So 8 minutes to print that. I can't imagine how fast that was going, but it's, so it's going, and it's really, really messy. It kind of resembles the one on the right, but not really. So as you move from left to right there, obviously it gets a lot finer. So that one on the left, it went from 8 minutes. One on the right is 2 hours. So it's the same size, but you're getting that finer detail and much smaller layer height. So it's smoother. You're still not going to be able to eat out of it, but it is smoother and a lot nicer. So it just kind of depends on what you're doing. If you are proofing something and it's not going to be your final one, you're just kind of testing it, I would go for the faster one. But it also is not going to be quite as strong because there's bigger layers, so it's just not going to be quite as strong. So these are considerations to think about when you're designing your print and choosing your settings. So I do want to point out that is a little bit different spot for that, where I got that. I have been trying to track it down. I'm not exactly sure where it originally came from, unfortunately. So talking about shells or walls, I kind of mentioned this a little bit, just briefly, is something I would want to change for strength. So as you're looking at your profile settings, there on the right of the screen when you've got Cura open, you have the option to change the shell. So the shell is talking about the bottom part of it. Basically, it's all the outside portions of it. So using this here, it's that top layer, the sides here, and then the bottom layer. So you can control all three of those. And you can do other things as well, but those are the ones we're really concerned about. So on this particular one, the wall line count is 3. That is the standard. I have been starting to push mine up to 4, depending, of course, on what it is. So this is a great illustration from Ultimaker. And this shows, so this one over here has 2 walls. And so the green that is denoting the walls. So here you can see it's 2, and here it's the 1 on the right. So what happens there is since it's a thicker wall, it's always going to be a little bit stronger. So this is not the outside layer. It's like one layer in, more or less. So one of these days I'm going to print one of these, but I haven't done it yet. So each one of those on this particular object, each one of those comes out, you can kind of feel it. So you can see that one layer there, it's pretty thin. And then when you get to 30 walls, and these are 1 inch, by the way, when you get to the 30 walls, there's no airspace in there. It's all just a solid mass. So, this is really where the strength of your print comes from. So you kind of have to make that decision about, do I need it to be that strong? Because it will, of course, increase your print time as well, because it's more dense. It's going to take more filament. So that is the gist of the shell. So let's talk about infill. So now we're moving kind of more to the inside of the print. The standard infill is 20% and triangles as the pattern. And we're going to go, there's another link there that's, again, Ultimaker. We'll go to that in just a second. But here is the same guy made another fantastic illustration. So that's kind of the whole thing. And then this next picture is looking down at it. So you can see down here at the bottom left, that's probably not going to be very strong. This is going to get a little bit better. And of course, these are going to be, they're going to be stronger. The whole print's going to be more dense. It's going to take a little bit more filament. Many times you can have this trade-off between wall strength, and infill. So you don't have to have strong walls and strong infill most of the time. You can kind of swap them. I used to have more infill, and I've gone to stronger walls rather than infill. So, but it also just depends on what you're doing. Another aspect of this is your kind of your ceiling, your top. If you have a low infill, you're going to want to have more layers on your top so that you don't have what they call pillowing. So, and that's when it kind of goes in on your top layer. So, and there's tons of discussion and argument and information depending on where you go and what you look at. So, experimenting is the best thing to go. So with Cura and some of the other slicers as well, they'll have different infill patterns. So some of these are stronger than others. People fall in love with one particular pattern. My attitude so far is it's inside, I don't care. But it kind of depends on what you're doing. Sometimes you may want something that's really, really strong. So some of the patterns are stronger than others. It just kind of depends. And they're, again, this is one of those things you can get way deep into it. I'm not going to do that right now. All right, so let's move on to supports. So supports are not always needed. This is a great illustration again from Ultimaker. And the one on the left, you see the red spots on there. That is where it wants support. So, and unfortunately, I don't have my example here. It's at work. But you can do a I've just forgotten what it's called, but it's a curve, and it looks kind of like this. It's got a base on it, has this, and it's the different angles. So it starts out, pretty much 90, and then as it goes out, it has more angle to it. And so the idea there is that you print it, and it has what the angles are on it, and you don't print it with supports. And then as you go and have more hang, you'll see looping underneath. And I have a slide here in a second that'll show that. But you can choose at what angle you want the supports to be. So this one obviously has no supports. This one here has an angle, an overhang angle of 70. So that means that once this arc here, this curve gets to 70, it starts putting in that support. And then here, it's coming quite a bit in further. So this one is, this one's 70, this one's 45. So depending on your printer and the filament and the time of day to an extent, because heat, all kinds of different things will affect it. If there's a breeze, like I said, there are lots of things that can affect it. So testing is good. Having that angle support or angle test is a good thing. So you can do one of those. I don't have to do it for every color, but you can do it for at least every type of filament. And sometimes the different brands of filament will behave differently. So if you're having some weirdness, that's not a bad thing to test. So there's lots more information on that. So this is a picture of the back of they're like two bookmark holders. So looking at the back here, the one on the left is PLA. The one on the right is nylon. But this is one of the first, not the first thing we printed on this printer, but this is something I designed, and it's the first thing I designed that we printed on the printer. And we were testing various things. So the PLA, I did not use supports. So this area right here is problematic. I didn't really feel the need for supports, honestly, because I didn't really care if I had some stringing. And it turned out pretty good on this one. I got away with it. I did not really get away with it with the nylon. So the nylon had some issues. It is a much pickier filament to use. And so you can see I have some issues here, and this right here is where it sagged. So since there was nothing supporting here, and it's building it up in layers, if there's nothing underneath it, and all of a sudden you have a horizontal or a steep angle, it's just kind of printing out in air. And so you may have all kinds of drooping and sagging. So depending on, like I said, a whole bunch of different things, experimentation is your friend. So sometimes you'll get away with it, sometimes you won't. So I would say that one on the right is not a wonderful print. I don't even know where that is. Oh, I think it broke. That's right. It broke. So it broke right here. And looking at it, you can see why. So I don't think I had the temperature up. I still haven't done all the testing and calibration for that particular filament that we really need to have before we run it. So moving on to different support material. So this is Grogu, Baby Yoda, obviously, and he's about this big. So he's little tiny. He's about 2.5 centimeters, just right around an inch ish. No, I take that back. It was 28 millimeters. So yeah, just around an inch. Anyway, that the picture, this bigger picture here, is water soluble filament as a support material. And so in this case, we used both of the nozzles, and we had the PLA on one and the PVA, polyvinyl acetate, which dissolves in water over a lot of time, but it does dissolve in water as our sport filament. And so I left it, put it in a cup, and I put hot water in it, and I put it outside my office. And every so often, somebody would come by and kind of shake it to get it to dissolve a little bit. And it took us, I don't know, 3-4 hours of just kind of messing with it every half an hour. So it was like a group project. It was pretty fun. But anyway, that allows you to have these areas like this here is almost a 90 degree. So it really needed that support. And his ears out here, you can see it needed it. I'm not real sure why his eye has some support. It didn't really need it. But anyway, you can adjust that. That's not something I mess with very often. It's just not, I haven't done it yet. So that is support. So let's talk now about build plate adhesion. This is one of those things that a lot of people struggle with. And I continue to struggle with it from time to time. So build plate adhesion is how well your print sticks to your print bed. Just a sec here. So I have glass. It's really dirty at the moment. I need to clean it. So this is borosilicate glass. It's Pyrex, essentially. It can handle a lot of temperature change because it's going to heat up to typically around 60 degrees Celsius. And so again, we're not in imperial measurements here. So this is the clean side. You can, if you can hear, there's not much there. There's a lot of, I've got a lot of glue on there. That's what that is. And it's just a glue stick. And so the idea is that I'm not gluing it to the surface. I'm adding just a little bit of texture so that the print can grab onto that. And you can kind of see where I've had a lot of circles on there. So after 3 or 4 prints, I will typically just take it and wash it off at the sink. They don't all come out that easily. Mine's a retrofit hack, shall we call it. So you can't see it terribly well, but yeah, it's not professional. We'll just say that. But it works. So one of the things I like to do is you have a bunch of different options for how to encourage it to stick. I prefer a skirt, and a skirt is typically 1 or 2 lines, essentially, that go around the print. And you can change the settings on that. I think on mine I have 2. I have to do 2 right now. The one at work does one line, and you can adjust how many times it makes that line around it, that outline. You can adjust how close or how far it is from the print. Look up all kinds of different advanced options that I almost never mess with. But the reason I like this skirt is because it's really easy to see if you're going to have some kind of adhesion problem or if your bed's not level. So the bed, that's the glass plate in this case. It doesn't have to be a glass plate, but that's what mine is. So that bed, it doesn't have to be level to the floor. That has nothing to do with level. It's level to where that nozzle is. So if your bed is not level, so let's say this is your bed. If you can see, there we go. Let's say this is your bed, and this is down and this is up. Well, your nozzle is going to be all the same height. So if your nozzle is meeting here, and you go over here, there's not going to be any adhesion over here. So it needs to be a flat plane to the nozzle. And so as you're doing that skirt and it's going around, if it gets wider or gets narrower, that's a sign that your bed is not level. And so you need to stop and level everything and then go. Because if that first level is not the way it needs to be, then your print is pretty much guaranteed to fail. You're going to have problems. If you don't have problems immediately, you will have problems later down the line. So that first layer is absolutely critical. So a skirt is it allows you to do what they call live leveling, which is where you're watching it and you're leveling the bed. So a lot of different printers will have, they all have a screw that tightens or loosens a spring that moves that bed up and down. So you can have, it's typically 3 of them. So you've got 1 in the back and 2 in the front. So it's not as bad as it could be, but it takes a little bit of fussing. So that's fun. And then you also have to assume that your glass is level. That is not always the case. So once you get into leveling your bed, there are people who are incredibly picky about it. And they're probably not wrong, but it's more than I'm willing to do. So I still get pretty good results. So anyway, the skirt allows you to do some live leveling. So a brim is one that comes out from the piece, and you have to either snap or cut that off when you're done. A brim will do a couple of layers of kind of a bigger footprint and then start printing on there. And that's if you're really, really, really worried about raft is the one where it's a couple layers. That's if you're really worried about it. If you have something that's really delicate, you may want to do that. If it's top heavy, you may want to do one of those. So because if you have just like a little tiny footprint and then you have something that's up here, that might be not real steady. If that's your only point, then it could break. So as that nozzle is moving, it could actually knock it off. Had that happen. So it just kind of be aware that there are a couple different things that you can do with that skirt. So again, Ultimaker has these great illustrations. So this is the skirt. You can see it just has the one line around it. The brim comes out a little bit, doesn't do too much. It's 1 layer, and then the raft, you can see it's a bit thicker here, and it comes out. So this is when you're really serious. And both the raft and the brim will need some cleanup work at the end because you've got to either break or cut that stuff off. Okay, so this is one of these. This is the file, and it just happened to be blue. You can change the color, but in this case, I just left it. So this is an object that I imported, and I have the little sidebar there that is standard in Kira. So a couple things to note here is it has this blue outline, which means it's active. So it's not going to assume that you want to do something unless you have it clicked. So once you have it clicked, you'll see these will actually, you can interact with them. So right now, this is nozzle 1. If I were to click on it and then click on nozzle 2, I think you right click on it and you can choose which nozzle you want it to be. So bunch of different settings here. We'll go through them kind of quick. No, we're doing okay on time. So this is where it is on the build plate. It doesn't have to stay in the middle. You can choose wherever you want to put it. But that's kind of a reference. So you can either click it and drag it, or you can put in specific numbers. So because this is a 3D thing, you can go side, front, back, and up and down. So you obviously wouldn't want to put something above the build plate unless you had supports underneath it. I don't really know why you'd want to do that, but you theoretically could. So you can, it doesn't have to be touching the build plate, but if it's not, you're going to need supports. So kind of just looking a little bit closer there, that is your X, your Y, and your Z. So X, Y, and Z. You can move all those. So next is scaling. And scaling can be kind of fun. One caveat with scaling is you don't want to go too crazy with this. Like if you do 200%, you can probably get away with that. I think I did 500%. It did not do well. It did not. So, and that is basically because you are doing strange things to the underlying mesh. It kind of doesn't have enough points on it when you scale it up that big in a slicer. Now, if you were to take it into Tinkercad, you would be able to, you could have a lot bigger success with that because it's adding more points to that mesh. So you can scale, it's obviously 100%. I often unclick uniform, I sometimes unclick uniform scaling, and then I will change one dimension. So for example, this is the original size, there we go, of this little cat cookie cutter. There we go. And I scaled it up to this one. But I didn't want to scale the height any different. I wanted the height to be the same because I didn't need my cookie cutter to have, you know, twice as high walls. So I only did, I think I did 150%, maybe, I can't remember if it was 150 or 200 on this one. And so the walls got a little bit thicker, not appreciably, but I left the height as it was and just changed the X and Y, not the Z. So that's one of those times you would want to unclick that uniform scaling. So you can play with that. It's one of those things, just kind of, you know, play with it as you will. So rotation, there's so much fun stuff in this one. I have a video here in just a second, but I just want to point out, so you have your object here. This one right here is to reset it. This is to lay it flat, and by flat, it's like this. It doesn't mean it's going to find the flattest side. It means it's going to put it kind of back to where it was as far as flatness that way. And then this last one here is whichever face you choose, it will do. And I have a video coming up here in a second about that. So a little closer view of those. They added that snap face one about a year ago, and oh, I love it so much. Anyway, okay, so I'm going to start this video. I got to turn my mic around. All right, so now I'm going to talk about the rotation function. So you click on your thing, on your model, whatever it is that you're slicing or that you were going to print. And if you have the rotation icon here selected, it's going to pull up a couple of different options. So reset will bring it right back to where it was when you first imported it. This is to lay it flat. So right now it already is pretty much flat, so it didn't do much. But this one right here is my favorite tool. So when you click on this right here, whoops, there we go. And then you can click on whichever face you want to have on the build plate. So if I print there, it'll go there. If it's kind of, this one's round and so it's hard to see. But this is really the face that I want down. So it centered it, it put it exactly where I want it, that is just fine. So I could also say, oh, that's not quite what I wanted, so I can click on that one, and now it flipped it. So it's a really fast way to get it to where you want it to be. So let's say for some reason I want to put it on that edge, and it did it again. So let's say that I just want to spin it. So that's the way I do that. There could be other ways, but that's the way I do it. So these rings here will allow you to rotate it in a couple of different ways. So the blue ring here will turn it in a circle, kind of on a flat plane. The red one will turn it in a circle. You can kind of see it moving there as I go around. So it kind of spins it. Depends on what the object is too. And then the green one will spin it a little bit different way. So let's say that you've played with it a little bit and it's really not where you want it to be. So in this case, I'm going to go ahead and rotate it by holding down the mouse button. And that's the face I want. So I'm going to go back here, click on that, and there we go. We're good and ready to go again. I just move that to the center-ish. And oh, it's not close. There we go. Center-ish. And we're good to slice. All right, so moving on from the last video where we rotated it and got it in the middle, now it's time to actually slice it. So the slicing is going to put it into layers that the machine can then lay one layer down and then the next one build it up. So let's look at our settings and just check before we hit that slice button. So we are at a normal resolution, 0.15 millimeters. That's pretty good. I don't really like the 20%. So I'm going to go back and change that. So we have all of our options here. Layer height is good. I'm going to change the wall count to 4 because that's going to add a bit of strength to this particular one. Everything else there looks good. For my infill, I don't really want it 20. I want it 10. That's kind of a personal preference thing anymore. Some people like it more, some people like it less. I don't really feel the need. So I've been happy with the strength of the 10%. So I'm not going to worry about any of these other ones except for, let's see, we don't need any support. It's all 45 degrees or less, which is pretty good for that particular printer. Build plate adhesion. I always have the prime blob enabled. What that does is that puts a little blob kind of right down here in this front left corner. And that just helps to make sure that the nozzle is primed, everything is flowing properly, and it just helps kind of warm up that whole process. Typically makes for a better print. So I'm going to change it from brim. I do not like brims, personally. I'm much happier with this skirt usually. And it's just more post-processing that you have to do, basically. So unless you really need it for bed adhesion, and there are certainly some prints that do, I would usually try to get away with the skirt first. So the skirt, it can be a couple of different things depending on what your settings are, but it's typically one line of filament that goes outside the print. And it's just a good time to really watch that and make sure that your bed is level, because if it's not, you may see that in that skirt. And make sure that that first bead is looking good, if your bed's not too high or too low. It's just a really good way to kind of really watch and make sure everything's good. So we have 2 extruders here. I'm only really worried about one most of the time, so we're not even going to worry about the dual extrusion. So at this point, I'm going to go ahead and disappear that stuff, and we're going to slice it. It'll take it a little bit, depending on how complex your print is. There we go. So this particular item is going to take 5 hours and 49 minutes. So we could save it to a file, we could save it to some removable media, but I'm going to go over into preview. So you can also, if you watched, you could see it went from prepare to preview. And now it shows there's my little skirt down there. I'm going to zoom in just a little bit and move it around. There we go. So this thing over here on the right is each layer. So it's got 676 layers, and if we bring it down to 1, we can watch it. We can bring this up and we can watch it and see how it's going to build. You can see there's that infill starting, and you can see that inner ring. So that ring's going to go all the way through this particular one. You can see it as we go. Let me rotate it down just a little bit so you can see. So in this, you can really see how those walls are going to add a ton of strength. So just kind of watching it to make sure there's nothing unexpected. There, it's building right there. It's starting to build the bottom of that little slot, that channel. And coming up, and then there's the top. So this one down here that's kind of covered by the save to file thing there, this actually is the path that the nozzle is going to take. So I don't usually worry about that. If you have a really complex print, sometimes it's interesting to watch that. So that is the slicing process. So then you could save it to file. You could save it to removable media. One thing I do want to mention is that when you do this, it's going to save it as G-code. So you will not be able to come in and alter any settings. So if you want to save it, you want to, so that you can still alter it, you're going to want to save it as a Cura project. And what that means is that then you can go back in, and so you can say, oh, you know what, I don't really want it to be at that layer height. I really want a bigger or smaller layer height. Or I want to change the number of walls, whatever. You will not be able to do that in Cura if it's in G-code. There are ways to edit that. But for our purposes right now, that's way more advanced than we're going to get today. So for our purposes, just make sure if you want to edit it later that you're saving it as a project. So that's it. We can now send this to the printer. So you can, I need to contradict myself just a little tiny bit. There is some G-code editing in Cura, but again, that is not, I'm not into that yet. I tried earlier a couple years ago and confused myself. I'll get there, but not today. All right, so now I get to share things I've learned. A lot of them have been the hard way. So, Caitlin. Yeah, so we all have these things that we've learned the hard way.
I'm like waving at people walking by me in the office. It's like I haven't seen people in so long.
Oh, too funny. Yes, yeah, I love it. Okay, so as you saw, manipulating Cura, it kind of looked easy. When you first start, it's not. It's very confusing sometimes. It's very awkward. Very, very awkward. Just relax and breathe and resign yourself to the fact that you're going to hit a lot of the wrong button and move things around. So your left, and some of this seems obvious, some of it is really not. So the left button is to select and interact. So just like normal, that's your regular, your index finger mouse button. Your right button is to rotate the view. So that's how you spin it. It's not up and down like front, tilt, or moving the bed. So the way you move the bed or the build plate up and down, because as you're rotating it, sometimes it'll be, you'll end up seeing like the bottom of the build plate. You won't be able to see the object at all, or it'll be way down here. So the way you do that is you actually hold, let me see if I can bring this up. So most mice, and mine's a little bit weird, but most mice on their scroll bar, you can actually push that down. I had no idea until I started playing with Kira that would actually do that. So this is one of those learn the hard way things. So this scroll button, as I'm moving, my things there, but this scroll button will move to zoom in and out, but it will also move the build plate. So that's one of those things that you just kind of got to get used to. I have a really fancy mouse at work. I think it's like a 7 button or a 9, but it's ridiculous. I love it so much. Anyway, those buttons do different things as well. So that's why down at the bottom there, I say different mice have different controls. And wow, yeah, sometimes they'll be totally different. But just kind of be aware that center scroll button thing is the thing. A while back, a year and a half ago, one of my coworkers and I were playing with the print, and we got into some of the post processing or changing of the extensions. Don't do it, or if you do, save it and then work on a new version. So things can go very interestingly wrong. We made some clown wigs. I'll show you what I mean there in a minute. So the other piece of advice I have is to check your infill and build plate adhesion settings, and then use the preview mode to check. So you check all those settings, you slice it, and then go into preview mode, and then just do that zoom up and down and make sure that everything is the way you want it. So now we're into the examples. So I strongly encourage you to save whatever you're working on and then play. So if you have something you think you might be pretty happy with, save it and then work on a new version. So the Control Z or undo is not infinite. So just be aware of that. So some examples of 3D printed objects. So one of the things that got me really excited when I was first starting to 3D print are lithophanes. And so lithophanes used to be created by carving ceramics. And now we can do them with 3D printers and some software. It's pretty cool. So this one obviously is Loki. This one was printed flat on the bed. So it's not the best resolution because you're limited by those layer heights on the resolution this way. If you print your lithophane up and down, you have your layer height this way, but you also have your width, and it's that width of the lithophane that basically blocks the light from coming through. So if you can kind of see on this top part here, this is where there's a thick part, and that's this shadow right here. So it's a little bit of a confusing thing at first, but it's a really fun thing to do. So here are some of those bookmark holders. I had zoomed in on some earlier. This is a little bit, the one on the left is the first one I did, and it didn't have enough of a back part on it so that it would, you put bookmarks in there and it would fall over. So the blue part on the bottom there was my extra foot so that we could load it up with bookmarks. So you can see just a tiny bit of stringing down here. So this really could have used a little bit of support, but honestly, it wasn't. I still don't really care. It still works. You can print lots of very utilitarian things. So this right here is something that one of our shelvers, who's incredibly creative, came up with. Lucas he's very good at 3D modeling. So this is a dispenser for our golf pencils. So the idea is that we would load it up, people would take them, and then they don't put them back because COVID, we don't really want things back. So that's one of those things that we thought we could play with. And then a handle for an Allen key. So the Allen key goes here because we kept losing the Allen key. And so with the handle, we've managed to keep it. So this little figure is 2 inches tall. So it's obviously quite big, but the reason I kept this one is because the supports are back here. He printed it flat so that he could have this dimension here. So that was an interesting one. Not everything is successful. So this one, I did not have good bed adhesion. It turned out the bed was too low. So the first layer would not squish tight enough to the bed, despite having some glue in there. So it just kind of would push things. It would do it a little bit and then push them. And so there's a lot of stringing in there. This one did work. This is an octopus, so I printed this in place. It's all little joints here, but it has supports down here. You can see down on the bottom. Yeah, you can zoom in here and see where these are the joints where it prints in place. So each tentacle printed in place, and then it had these supports that we had to chip off or break off. So, whoops, sorry, going the wrong way. So I also I do a lot of crafting, and so this is a bobbin for one of my spinning wheels. My son made this thing here, which holds his phone, and it's a custom outlet cover. So he really wanted something different than he'd seen. So he came up with this, and I thought it was brilliant. And so he's got it in his, I think he's got it in his room now. This here is one that I printed in 2016. It's the first thing I printed on my printer, and I have had it on my keys ever since, and it works great. And then I printed this little quarter keeper, and these are wonderful. If you shop at Aldi, you always have a quarter on your keychain if you have one of those. This is a lithophane with supports on the front, and so these broke off really, really easily. I still don't know why he decided to print it with supports, because most of the time they don't need them, but it looks a little scary, but it's not. This is another bobbin that I printed. So these, my cost to print these is about $3. To buy one of those bobbins is anywhere from $20 to $40. So it's definitely worth my time to print them. And so this part here and this part here were printed, and this is a piece of pipe. So just PVC. So other things you can do, this is a customer that came in and printed, this goes on the blinds, the mini blinds, the header part of it. So the clips, as I'm sure everybody knows, the clips break a lot. And so he found some, and we printed them, and he put them back on. And then Grogu, we've already seen Grogu. This is a thing that I printed when COVID first started. We had a big push to make masks. And so these are holders where you pull the fabric through and it kind of folds it for you. So you can use it for ties on the masks. This is a holder for thumb drives with STL, or not STL, cards. You can do all kinds of different things on there. So it has some different card storage. There we go. You can see it on the site. So super useful. All kinds of different things around the house. I've printed hooks. So these are in my shower. I have another one that goes on the other side as well. This is a base for shaving cream, because I got tired of it rusting. So that keeps it from rusting. This is clown hair. This is a mistake. We didn't mean to do this. So this was one where it fell over and then printed in air all night long, because this was like a 23-hour print, something like that. So it looked great when we left, and then when we came back, it was like, oh no, that's not good. And so that was a mechanical error where it fell over. This one here, I don't know what happened. I still don't know what happened. We think it was a G-code error, because basically what happened was it was printing and then it would shoot out to the side, so that it would come out to the side and string out in the air. So there is a neat Christmas tree file that uses that technique, but that was not what I wanted to do. So have fun, save it, and then play, and so you can have different stages. And then once you get more confident, you kind of understand how your machine works, how the slicing software works, you get more confident and not have to to save quite so often. But save, you'll never regret saving, or rarely regret saving. So if you have any questions later, that is my email address. Email me. If I can't find an answer, I will find someone who can find the answer. So that's it. That's all I got. Ooh, and we're exactly on time.
If anybody has questions, feel free to drop them down in the chat. I did have one question for you, Kat. I know with COVID going on right now, the libraries are currently closed. We are opening a few of our branches next week for express service, but how can people use the 3D printers while we are just doing express service and curbside?
So we have a couple of different options. Probably the best way to do it right now is if you go to our website and you go to our COVID page, it'll talk about how to pick up prints and how to send prints so that you can have them printed and come pick them up. If you scroll down to the bottom of that, it mentions 3D printing. So we actually have a portal. If you click on that, you can put your name, your library card number, your contact email address. You can attach your file. It'll ask you a couple of questions. We will probably email you back with further questions because every print is different. So the web form there is a good way to start. And then we'll kind of ping back and forth from there. But email is definitely the way to go, as opposed to a phone call, because I'm not always at my desk, and I know the other people who run the printers are not always at their desks. So your best bet is going to be an email, and then if we have to, we can call from there. But email is definitely preferred.
And do you guys charge for the use of the 3D printers?
We only charge for filament. So if you have your own filament, we can work with you on that. I have one person who is a heavy user, and I actually have some filament in my office of his. That is not something that we typically like to do. Honestly, it's a fair amount of liability for us, and it also means he can't use it if it's in my office. But he prints like a once or twice a week. So it's one of those things that it made it worth his time. So if you use our filament, it is 10 cents per gram. So that's just straight across the board, 10 cents per gram. That does include things like the brims or skirts or wraps, that kind of thing. So we do take all of that and do that. And that just covers our cost. So that allows us to continue to purchase filament so that we can offer this service.
Well, Kat, thank you so much for this introduction today. I will make sure to send out both the slides and a few of the links that Kat mentioned throughout the talk, as well as a link to this recording when I'm able to get it edited and uploaded online. But I hope everybody has had a warm and safe week. I know it's been kind of wild here in Oklahoma the last couple weeks. Next month for our Tech Talk, we are going to be doing a class on Mac computers for beginners. That'll be March 26th from noon to 1. So look forward to that. And I hope you all have a great weekend. Thanks so much, Kat.
Thank you. I appreciate everybody for being here.